Hello students. Today's first question is: a small school has 3 foreign languages, one in French, one in Spanish and one in German. How many of the 34 students enrolled in the Spanish class are also enrolled in the French class? So let us first draw a Venn diagram. Since we have been asked about those students who have been enrolled in Spanish class are also enrolled in French class, let us suppose that to be Y. Right? Now, this to be Spanish and this circle represents French class students. Let us suppose this to be X and Z. Now, since we have been given that how many of the 34 students enrolled in the Spanish class, so that means X plus Y is equal to 34. Since in the main statement it has been given that there are three languages, French, Spanish and German, but there is no account of German, so we won't be taking German language in the account. Right? If there was any need, we will draw one more circle over here. Now, how many of the 34 students enrolled in the Spanish class are also enrolled in the French class? So we need to find those who are enrolled in the Spanish class, that is Y, and also enrolled in French. So that means we need to find the value of Y. And X plus Y has been given to be 34. Now with this information we will move to statement first. Statement first tells me there are 27 students enrolled in the French class, 49 students enrolled in either the French class, the Spanish class or both the classes. So 27 students are enrolled in French class. So what does that mean? That means Y plus Z is equal to 27 and 49 enrolled in either the French class or Spanish or both of these. So that means X plus Y plus Z has been given to us as 49. Now X plus Y is equal to 34 and Z plus Y is equal to 27. This is from main statement and this is from statement 1, Y plus Z, Z plus Y is equal to 21. Now if I add this, I would be getting X plus 2Y plus Z is equal to 7, 4, 11 and carry 3 to 5, 61. Or I can write this as X plus Y plus Z plus Y equal to 61. But I know X plus Y plus Z is equal to 49, sorry. So I'll put this value over here. So this implies 49 plus Y is equal to 61, which further implies Y is equal to 61 minus 49. Or this is equal to 12. So Y is equal to 12. So which I needed to find. So I can say that statement A alone is sufficient to answer my question. Fine. Now moving to statement 2. Statement 2 tells me 1/2 of the students enrolled in the Spanish class are enrolled in more than one foreign language class. So this gives us that 1/2 of the students enrolled in the Spanish class. So in Spanish class, enrolled students are X plus Y, which is equal to 34, and half of this is, so that means 1/2 of X plus Y, that is equal to 70, are enrolled in more than one foreign language class. So that means this number 1/2 X plus Y is equal to 17 is that number which has been enrolled in more than one foreign class. So that can be French. So we can assume this to be French plus German, or there can be possibility that these 70 students have been enrolled in French plus Spanish, but we don't know specifically. So we can say that statement B is not sufficient to answer our question. So for this particular question we will mark of statement A that statement 1 alone is sufficient to answer our question. If S is a set of 4 numbers W, X, Y, Z, right? S is a set of 4 numbers W, X, Y and Z. Is the range of the numbers in S greater than 2? So we need to find that range of S is greater than 2. Range basically means greatest number out of these 4 minus the lowest should be greater than 2. So we need to find this. Now with this information we will move to statement 1. Statement 1 tells me that W minus Z is greater than 2. Now since the difference between two numbers is greater than 2, Now let us, there can be two scenarios. Let us suppose W and Z are greatest and least. Greatest and least, right? Let us suppose this. Then W minus Z is greater than 2 means that is giving us a range which is greater than 2, right? Or let us suppose X and Y are greatest and least. So that means we have been given nothing about this. But since, let us consider that scenario in which W is having value 3, right? X is having value 5. Y is having value 5 minus, so let us suppose 2. So this is W, this is X, this is Y, and Z has to be 0, right? Because W minus Z, we need to keep that greater than 0, greater than 2. So W minus Z is 3 minus 0 is greater than 2. Now, since X and Y are the greatest, X is greatest and Y is the lowest, and their average is 5 minus 2, which is greater than 2. Since W and Z are not the greatest and the least, even though if the range, if their difference is greater than 2, that means if X and Y are greatest and least, their difference would be greater than this. Or in other words, we can say that range has to be greater than 2, given that out of 4 numbers, the difference between 2 numbers is greater than 2. So we can say surely that statement A is sufficient to answer that the range of this set will have to be greater than 2, provided if WZ are greatest or least, or they are not. Even though statement A is sufficient to give us this answer that the range of the set will be greater than 2. Now, moving to statement 2. Statement 2 tells me that Z is the least number in S. Now, if Z is the least number in S, that doesn't give us any value of Z. No value for this is being given. So we can't find the range. So we will say we can't find the range. So for this particular question, statement B is not sufficient to answer our question. For this particular question, statement A alone is sufficient to give us the answer that yes, range is greater than 2. Last year, 3 by 5 of the members of a certain club were males. Now let us suppose total number of members last year were M. Sorry, don't M. Let us suppose that to be N. Right? Now, it has been given that 3 by 5 of the members, that means 3 by 5 of N, were males last year. Right? Now, this year the members of the club include all the members from the last year. So that means N plus, right? Plus some new members. Is the fraction of the members of the club who are males greater this year than last year? So some members have been added. So let us suppose that A members have been added this year, and out of this X members are male, right? So total members now will be N plus A. N were the last year and N plus A will be total members this year. Now, last year there were 3 by 5 of N, which is equal to, which we have assumed to be M, right? Males. Now this year X members have been males. So that means 3 by 5 of N plus X are the total number of males this year, right? And these are the total number of members, right? Now the question is the fraction of members of the club who are males greater this year than last year? So fraction basically means the number of males this year is 3 by 5 N plus X, right? Now dividing it by the total number of members this year is N plus A is greater than fraction of members, male members last year. So that will be 3 by 5 of N divided by total members last year, that were N. So N and N gets cancelled. So we basically need to find whether 3 by 5 N plus X divided by N plus A is greater than 3 by 5, right? Now shifting this to this side, we will be getting, this implies 5 into 3 by 5 of N plus X greater than 3 N plus A, right? Or I can say 3N plus 5X is greater than thrice N plus thrice A, right? Or 3N gets cancelled, 5X greater than thrice of A, or I can say that X is greater than 3 by 5 of A. So basically we need to find whether x is what? X is the number new male members this year is greater than 3 by 5 of A. So A is the number of members added, so that is 3 by 5 of A, right? Now with this information we will move to statement 1. Statement 1 tells me that more than half of the new members are male. So what does that mean? New members are A and this is X. So we have been given that X is greater than 1 by 2 of A, right? Because half of A will be, number of male members are more than the half of the new members added, right? And we need to find whether X is greater than 3 by 5 of A. Now let us suppose some values and try to evaluate this. Now let us suppose A is equal to, that new members added are 20. In that case, X will be greater than 1 by 2 of 20. That means X will be greater than 11, right? Sorry, X will be greater than 10, right? Now let us suppose, now we'll try to calculate this. X, is X greater than 3 by 5 of 20? So 5, 4, so X has to be greater than 12. Now from this we are getting X is greater than 10. So let us suppose the value of X to be 11. In that case X is, sorry, this is 12. 4 into 3, 12. For this to be true, X has to be greater than 12, but X can also have value equal to 11, because from this we are getting that X is greater than 2 by 10 by putting value A equal to 20. Or we can have some other value in which X is greater than this, right? We can assume some other values also. Let us suppose N is 20, right? This is, sorry, A is 20. And since X is greater than 10, so I can assume X to be 16. X has to be greater than 10. And from here, inequality, X has to be greater than 12. And this confirms this, that X is greater than 12, which is 16. So here we will say yes, but here I can say no. So I am getting may or may not be condition. So I can say that statement A is not sufficient to answer my question. Now moving to statement 2. Statement 2 tells me the number of the members of the club this year is 6.5 the number of members last year. So what does that mean? That means the number of members of the club this year is 6.5 the number of members last year. So number of members this year is A. So A plus N, and last year were N, so that is equal to 3 by 5 of N, right? The number of members of the club this year, so total number of members this year are A plus N, and last year were N, so sorry, this is 6 by 5 of N, right? Now shifting like terms to one side, so A is equal to 6 minus 5 upon 5 into N. So this implies A is equal to 1 by 5 of N, right? So that means that that number of total members added this year is equal to 1 by 5 of the total members which were last year. So let us suppose the value of N to be 100, right? So A will be equal to 20. So number of members which have been added as 20, right? Now these are the members. Out of these there will be some males and some females. So let us suppose that number X to be equal to, again we can take these two examples. Let us suppose X to be equal to 11. In that case, again we have assumed N to be 100, so A comes out to be 20. So in that case also X has to be greater than 12, or X can have 16 value. Again we will be having same no and yes condition, so we can say statement B is also not sufficient and statement D is also not sufficient. Now using statement C, that is combining statement 1 and 2. Statement 1 tells me that X is greater than 1 by 2A, and statement 2 tells me that A is equal to 1 by 5 of N. Since we don't know specifically the value of N, there can be X which is having value less than 12, or X can have value greater than 12. So statement C is also not sufficient to answer my question. So we can say that for this particular question, statement E, that both the statements are not sufficient to answer my question is the correct option. Just because we don't know the value, particularly we are just assuming these values, right? If A, B, C are consecutive integers, and so we have been given that A, B, C are consecutive integers. Now it has also been given that all of these are greater than 0. So A is greater than 0, B is greater than A, and C is greater than B. Is the product A, B, C a multiple of 8? So we need to find that is ABC multiple of 8, right? Now there can be two scenarios in arranging this. Let us suppose first will be 1, 2, 3. Let us suppose A, B, C are having values 1, 2, 3 or 2, 3, 4. We are just taking an example. Now that can be case when A and C are odd, A and C are odd and B is even, or A and C are even and B is odd. There can be only these two scenarios, right? Now with this information we will move to statement 1. The product AC is even. Now we have been given that product AC is even. So what does that mean? Can this be possible when AC are odd? No. Only if first and last are even, that is then possible. So we can say that A as well as C are even. Now we have chosen the smallest integers which are even. So A into C, for let us suppose it to be 2, 3, 4, then A multiplied by C is equal to 8. And whatever be the value of C, ABC has to be multiple of 8. Fine. Now we'll consider some other examples. Since AC is even, so that means the starting number has to be even. So let us suppose some other example, 4, 5, 6. Now you see AC is even and 6 into 4 is equal to 24, which is a multiple of 8. Now take some other examples. Let us suppose 10, 11 and 12. So this is 120 and 120 is also multiple of 8. Right? So now why is it happening? Because since these are even, so they would be having 2 2's, both are even, so that means A and C will be having 2 square at least, right? And since this is also this even, so combining this they would be the multiple of at least 8, right? We can take some other example also. Let us suppose A to be 14 and C to be 16. So this is A, B, C. Now 14 into 16 divided by 8. So 8 into 2. So since AC is even, we can say that any of these ABC will always be a multiple of 8. So we can say that statement A is sufficient to answer our question that ABC multiple is 8. Now moving to statement 2. Statement 2 tells me that the product BC is a multiple of 4. Now product BC is a multiple of 4. Now we will take some examples for this. Now first is from this category we will take some case. So let us suppose to be 2, 3, 4. Now BC is a multiple of 4. BC is equal to 12 and it is a multiple of 4, right? And ABC is equal to 4 into 3, 12, 12 into 2, ABC is equal to 24 and it is also a multiple of 8. So we can say yes. But hold on. Let us consider some other examples. Let us suppose 3, 4, 5. 3, 4, 5. From this case in which A and C are odd, right? Now PC, which is equal to 20, is a multiple of 4. But 4 into 5 is 20 into 3, 60. 60 divided by 8, it is not a multiple of 8. So we are getting yes as well as no. So we can say that statement B is not sufficient to answer my question alone. So for this particular question, statement A alone is sufficient to answer my question. You might be wondering, I have not taken the product A, B, C in all these cases. Since A and C is alone a multiple of 8, any value of 5 multiplied by 8 will be a multiple of 8. You can check it also that 6 into 5, 30 into 4, 120 is a multiple of 8. Right? Here also, since 10 into 12 is a multiple of 8, then multiplied by 11, ABC will also be multiple. So in all these cases, ABC multiple of 8. All these cases. M and N are integers. So we have been given that M and N are integers such that M is greater than 6 and N is greater than M. What is the value of N? So we need to find the value of integer N. Now with this information we will move to statement 1. Statement 1 tells me that the greatest common divisor of M and N is 6. So that means that GCD, or what we call as HCF of M comma N, is 6. So we'll assume some values for this. Let us suppose M equal to 6 multiplied by 5 and N equal to 6 multiplied by 7. so that their GCD is 6 and this is 30 and this is 42. Right? So the value of n is 42 and m is 30. Now if we consider some other case, let us suppose m and n have 6 is their GCD, so it has to be in their values, right? So let us suppose m to be 6 multiplied by 7 and n to be 6 multiplied by 11 or 12, let us suppose. So this is 42 and this is equal to 72. Now in this case also, sorry, I have to keep this as 11. So this is 66. Otherwise GCD will change. So now m is less than n and the value of n is 66, but here it is 42, keeping the HCF to be 6. That's why we have chosen it to be primes. So we can say that statement A is not sufficient to answer my question because we are getting different values keeping the GCD same. Now moving to statement 2. Statement 2 tells me that least common multiple of m and n is 36. So that means LCM of m comma n is equal to 36. Now we have to keep the condition that m is greater than 6 and n is greater than m. So now let us suppose some values. Let us suppose m is equal to 4 multiplied by 3 which is equal to 12 and n equal to 9 multiplied by 2 which is equal to 18. Now the LCM of these is 36. Fine. And the value for m is 12 and n is 18 because we have to keep n greater than m. So the value of n is 18. Now consider some other scenario. Let us suppose m equal to again 4.3 equal to 12 and n equal to 9 multiplied by 4. In this case also the LCM is 36 but the value of n is 36. So we can say, since we are getting different values keeping the LCM same, we can say that statement B is also not sufficient, which means that statement D is also not sufficient to answer our question. Now we will move to statement C, that is combining statement 1 and 2. Right? Now 6 is HCF of both the numbers, right? Now combining statement 1 and 2 and keeping this that's in mind, that m has to be greater than 6 and n has to be greater than m. So the possible values for m can be 6, 12, 18 and 36 because LCM of m and n has to be 36. Now the possible value for n has to be 12, 18 and 36, right? Now you see in the value of m can't be 6. Why? Because m is greater than 6, so I will cancel out this also. And we need also to keep in mind that m is less than n. So if the value of m is 12, we will start pairing in the pairs m comma n. If the value of m is 12, then the value of n has to be 18, right? If the value of m is 18, then the value of n has to be 36 because m is less than n, right? Or I can have the value of m to be 12 and the value of n to be 36, right? Now we will calculate LCM and HCF for all of these. So let us suppose for 12 and 18. So 2, 6, 9, 3, 2, 3, 2, 1, 3 and 3, 1, 1. So 3 to 6, 6 to 12 and 12 to 36. So LCM for this is 36. Right? And 12 is equal to 2 square into 3 and 18 is equal to 3 square into 2, 9 into 2, 18, 4 into 3, 12. So HCF in this case will be maximum powers. So 2 into 3. So HCF will be 3, 6. Fine. Now let us calculate for the other two cases for 18 and 36. 18 and 36. So 2, 9, 18. 3, 3, 6. 3, 1, 2 and 2, 1, 1. So 3, 3, 9, 9 to 18 to 36. So here also LCM is 36. Fine. Now we will calculate HCF. So 18 is basically 3 square into 2 and 36 is equal to 6 square or 2 square into 3 square. Now here you see the minimum power of 3 is 2 and minimum power of 2 is 2. So 2 into 3 square. So that becomes 9 into 2, 18. So HCF will become 18. So that means this is out of question. Right? Because HCF has now become 18. Now for this 12 into 36. 12, 36. So again 2, 6, and here 18. Again 2, 3, 9. 3, 1, 2, sorry, 3 and 3, 1, 1. So 3, 3, 9. 9 to 18 into 2, 36. So here also LCM is 36. Now 12 is 2 square into 3. And 36 is 2 square into 3 square. So minimum power of 2 over here is 2 raised to power 2, and minimum power of 3 is 3, so that means 4 into 3. So HCF over here will be 12, right? So that means this is also not confining our statement that the HCF should be equal to 6. So the only solution which is left for possibility of M and N is 12, 18. So we can say that we are finding the single value for M and N, and in general N is equal to 18. So we are getting a single value by combining the statements. So we will say that statement C is the right option, that combining both the statements we are getting a single value for N. Machines K, M and N, each working alone at its constant rate, produces one widget in X, Y and 2 minutes respectively. So machine K, M and N, their constant rate is they produce one widget in X. K completes in X minutes, M in Y minutes and N in 2 minutes, right, respectively. If machines K, M and N work simultaneously at their respective constant rates, does it take them less than 1 hour to produce a total of 50 widgets? So we need to find that in less than 1 hour do they produce 50 widgets, right? Now, since we have been given that the machine N completes one widget in 20 minutes, so in 1 hour N will make 60 divided by 2 equal to 30 widgets. So this is given to us that N makes 30 widgets in 1 hour. Now we need to find that combining K plus M machines, if they are working at their constant rates, do they produce 50 widgets in less than 1 hour, right? Now with this information we'll move to statement 1. Statement 1 tells me that X is less than 1.5. So X is basically in minutes, and minutes X is less than 1.5. So that means the time taken by machine K to complete one widget is less than 1.5. Now, if this value starts decreasing, then the value of number of widgets will increase. So let us suppose it produces in 1.5 minutes one widget. So 60 divided by 1.5 will be equal to 40 widgets in 1 hour, right? So this is the rate at which machine K will produce. Now, if I start decreasing this value, let us suppose I take this value to 1. So 60 divided by 1 will be 60 widgets in 1 hour, right? So that means machine K is alone sufficient, then combining these will be definitely, they will be producing more than 50 widgets in 1 hour. But I have taken the maximum value for which is 1.5. So it is producing 40 widgets in 1 hour, and N is producing 30 widgets in 1 hour. So combining these, it will get 70 widgets within 1 hour, right? And we have not considered the number of widgets made by machine M till yet. So we can say that definitely they will produce more than 50 widgets in 1 hour. So I can say that statement A is sufficient. Reason being, 30 widgets are being made by machine N alone. Now we have been given that the efficiency of X is less than 1.5, and we have taken the minimum efficiency. If we start decreasing it, that means X will take less minutes and their number of widgets produced will be greater. Now at this particular value also, their sum is coming out to be more than 50, and we have not considered machine M till yet. So we can say that statement alone A is alone sufficient that to answer that all these three machines will produce more than 50 widgets in less than 1 hour. Now moving to statement 2. Statement 2 tells me that Y is less than 1 by 2. So now the efficiency of machine M has been given to us. So dividing 60 by 1 by 2, so it is 10. So this will be 50 widgets. Now again we have taken the minimum efficiency. If I start decreasing it at the, let us suppose Y is equal to 1 minute. In that case, in 1 hour it will make 60 widgets, right? So 50 plus this 30 is equal to 80. So this is M plus N working will make 80 widgets per hour, and we have not considered the efficiency of K till yet. So we can say surely that statement B is also sufficient to answer that yes, they are able to make the 50 widgets within 1 hour. So for this particular question we will say that statement D, both the statements are sufficient alone to answer the question. Stations X and Y are connected by two separate straight parallel lines that are 250 miles long. Okay. Station X and Y are connected by two separate straight parallel lines. Train P and Q simultaneously left station X and station Y respectively, and each train traveled to other's point of departure. So here is station X and here is station Y. Now these are connected by two parallel lines, right? Rail lines, and this distance is 250 miles long, right? Now train P and train Q simultaneously left station X and station Y respectively. So train P left from here, this is train P, and train Q left from here, and each travel to other point. So this is traveling towards this and this is traveling towards this, right? The two trains passed each other after traveling for 2 hours, right? So they, whenever they met, let us suppose they met over here, they passed each other when this has for 2 hours and this is also traveling for 2 hours, right? When the two trains passed, which train was nearer to its destination? So which was nearer to its destination? Whether this was nearer to this destination or this was nearer to this destination, right? So this is the question. With this information, we will move to statement 1. Statement 1 tells me, at the time when the two trains passed, train P had averaged a speed of 70 miles per hour. So what does that mean? That means since both the trains have traveled for 2 hours and train P has averaged 70 miles, 70 into 2 is equal to 140 miles per hour. So it has covered 140 miles. So this distance is basically 140 miles, which train P has covered when they passed, right? This is up to this. So we need to find which train was nearer. So this was nearer to its destination. So this whole is 250. So this distance will be, so train P is only 110 miles away, right? So this means this distance has been covered by train Q, and train Q is 140 miles away from its destination as it has to move from Y to X. So we can say train P has 110 miles away from its destination, whereas train Q is 140 miles away from its destination. So we can say surely that P is nearer to its destination. So which means that statement A alone is sufficient to answer my question. So I will say that statement A alone is sufficient to answer my question. Now moving to statement 2. Statement 2 tells me that train Q averaged a speed of 55 miles for the entire trip. Now, this says that Q averaged 55 miles per hour for entire trip. Right? Now, for first 2 hours, it might be that Q had a speed of 65 miles per hour. In that case, in 2 hours, it has covered 130 miles, and it has left 120 miles to cover, right? But we don't know anything about the speed of P, right? This statement is different from the first statement in a sense that in statement 1 it has been written that when the two trains passed, so it has become relative. So when the two trains passed, P had an average speed of 70 miles. So we got the reference of train Q also, that it has covered a distance of 110 meters when the two trains passed. But here nothing has been given us about the speed of P, or we can say that statement B is not sufficient to answer our question. So for this particular question, we will mark statement A is sufficient to answer the question. In the XY plane shown, the shaded region consists of all points that lie above the graph of y square is equal to x square minus 4x. So y is equal to x square minus 4x. So this is the graph of the shaded region and below the x-axis. So we can see that graph is below the x-axis. Does the point A comma B not shown lie in the shaded region if B is less than 0? So B has to be less than 0 because the graph is below the x-axis. So we need to find whether A comma B lies on this graph, right? And we have also been given that B is less than 0, right? Now putting these value over in this graph, so this is y intercept and this is x intercept. So b is equal to a square minus 4a. Fine. Now since b is less than 0, so we need to find basically that b is greater than a square minus 4a. Right? This is the question which we need to answer. Now, with this information, we will move to statement 1. Now, statement 1 tells me that a is greater than 0 and less than 4. Right? Now, if a, let us suppose the value of a to be 2, right? Then a square minus 4a becomes 2 square minus 4 dot 2, which is equal to 4 minus 8 equal to minus 4. Right? So, the point AB, which becomes 2 comma minus 4, will lie in the shaded region, and we can say yes, because b is greater than a square minus 4a. Right? Now, let us suppose some other scenario. Let us suppose the value of b to be minus 5. Right? Now, in this case, b is less than a square minus 4a. Right? You can consider some value for this. Let us suppose the value of a is 2. So a square minus 4a will be minus 2, and b is minus 5, and it is less than minus 2. So we are getting may or may not be condition. So we can say that statement A is not sufficient to answer our question. Now moving to statement 2. Statement 2 tells me that a square minus 4a is less than b, or I can say that b is greater than a square minus 4a. Fine. And this is what we need for the values of a and b to lie on the shaded region. B is greater than a square minus 4a. So this has been given. So we can say that statement B is sufficient to answer our question, and for this particular question, statement B is sufficient to answer our question. If a and b are positive integers, so we have been given that a and b are positive integers, right? We need to find whether cube root of ab is an integer. Now with this information, we will move to statement 1. Statement 1 tells me that square root of a is an integer. Now, let us suppose the value of a is equal to 4. So which means square root of 4 is 2. So that means this is an integer. Now, let us suppose the value of b to be 1. In this case, cube root of 4 dot 1 will be cube root of 4, which is not an integer. Right? Now, again, let us suppose the value of a to be 4, the value of b to be 2. In that case, cube root of 4 multiplied by 2 is 8 is equal to 2, which is an integer. So we are getting yes as well as, so here it is no and here yes. So we can say that statement A is not sufficient to answer our question. Now moving to statement 2. Statement 2 tells me that B is equal to square root of A. Now, if I put this value over here, I would be getting cube root of A dot, and in place of b I can write a raised to power 1 by 2, right? Or I can write this as a raised to power 1 plus 1 by 2, base is same, powers added, so 1 plus 1 by 2. Or I can write cube root of a raised to power 3 by 2, right? So this will be equal to a raised to power 3 by 2 into 1 by 3, right? So this is basically cancel. So this becomes a raised to power 1 by 2, which is equal to square root of a, and we have been given that square root of a is equal to b. So this is equal to b, which is a integer. So we can surely say that this is cube root of ab is an integer, right? So we can say that statement b alone is sufficient to answer my question, right? Thank you for today's lecture. Bye bye, take care. If you find any error in this, please do comment, and if you want some video on a certain topic, please do comment. Bye bye, take care.